All right, geometry. Hello, friends. We are into our concept on trigonometry. So this is probably one of the most important concepts that we cover this year. Trig. You're going to be using it in Algebra 2, Pre-Calculus, and beyond. Okay. So here we go. Pythagorean triples. That's what we're talking about today. Okay. So the Pythagorean theorem, I just want to remind you, I believe you learned this a while ago, okay, but the Pythagorean theorem, if we label this leg as A and this leg as B and the hypotenuse, the side opposite the right angle as C, okay, the Pythagorean theorem says that one of the legs squared plus the other leg squared will always equal the hypotenuse squared, okay? And so this is true for right triangles, okay? All right, so additionally, to tell that you have an acute triangle, okay, if you add the two legs squared together and their sum is bigger than the hypotenuse squared, you know you're dealing with an acute triangle, okay? And if you do the a squared plus the b squared, okay, and when you add those up, the hypotenuse squared is actually bigger. That means you're dealing with an obtuse triangle. So no, we're not going to deal with that too much, but I just wanted to throw that out there. Okay, so let's talk about our common Pythagorean triples, okay? So these are sets of three integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared, okay? And they're just ones that we typically see. They're very common, okay? And so we want to get really good at spotting them because it will save us time on problems, okay? So here's the first one, the 3, 4, 5, okay? The next one, the 5, 12, 13. The 8, 15, 17, and then the 7, 24, 25. These are just common ones, okay? And then the thing that you want to recognize is that also they're multiples, okay? So for example, if we times each of these by 2, okay, so 3 times 2 is 6, times 2 times 2, the 6, 8, 10 is also going to be a common one, okay? So these are like the baseline, okay, plus all of their multiples, okay? So if we times by 3, the 9, 12, 15, okay? And then let's just do some multiples, times 2 times 2 times 2, the 10, 24, 26, okay? Or if we times by 3, that would give us the 15, 36, 39, okay? And then the 8, 15, 17, if we times by 2, that's 16, 30, and 34, or by 3 is 24, 45, 51, okay? And then the last one, again, times 2 times 2 times 2, that would be 14, 48, 50, or if we times by 3, that would be 21, 72, 75. Okay, and so we just want to be able to spot these because if we can spot them, it will save us time on problems. Okay, so let's go ahead and jump to an example, for instance. Let's say we want to solve for x, okay? So x is over here, okay? And so the first thing that I want to notice is that this is a right angle. That means this is a right angle too, okay? And so I'm noticing right here, we have a right triangle, okay, going on over here. And I notice one leg is a 6 and the hypotenuse is a 10. Okay, and so let me just bring us back over here for a minute. Okay, as I'm thinking about my Pythagorean triples, check that one out, right? So if you can spot it quickly, it saves you from having to do the Pythagorean theorem. This length right here has got to be 8. It's a 6, 8, 10. Okay, all right, and then now, so a leg of 8 and a leg of 12, okay, I don't think that there's any common Pythagorean triples there, so that's okay, we'll just use the Pythagorean theorem. 8 squared plus 12 squared has got to equal the x squared, which is 64 plus 144 is x squared, which is 208 equals x squared, and then we'll solve for x by square rooting, and so x equals the square root of 208, okay? But we're not done. Remember, you always have to simplify when you can. So let's try and simplify the square root of 208. Okay, so let's break it down. That's 2 times 104. That's 2 times 2 times 52, which is 2 times 2. 52 is 2 times 26, okay, which is 2, this 2, this 2. 26 is 2 times 13. I think we've broken it all the way down to its primes. We've got a pair of 2's and a pair of 2's, so 2 times 2 comes out, that's 4. The 13's left over underneath. X has got to be 4 root 13. All right. Okay, so let's see if you can just think of your common Pythagorean triples. Okay, and you can use the Pythagorean theorem on this. It's just that if you can spot the triple, you can quickly, go ahead and pause it, but you can quickly jump to the answer of 75. Save yourself some time. All right, let's get to the lesson, or the practice.